Okay, so let's go ahead, guys, and do a few things on this. And then, okay, gas and oil. So remember, we're burning gas and oil. We're not burning electricity, but you still have to control it with electricity, right? So typical home, there are two ways of doing that system. We have the air, warm air. You circulate warm air, or you circulate warm water. Anybody has, almost all of you guys are warm air, right? A lot of people are warm air. Anybody has warm water? Okay, warm air is cool, right? You heat, you burn the gas, you blow it through all these coils, heat coils, right through the coils, right? And then you heat the coils, and then you blow the air right through these hot coils. That's how they get the heat. Everybody have seen the furnace where they do it? They have the natural gas here, and the natural gas is heating coils. These are not electrical coils, they're mechanical coils. You're heating them. And then from the other side, you have a big blower that's blowing the air through these coils that's hot. What do you think you get when you throw air through a hot coil? Mechanical coil, pipes. You get hot air from the other end. And they channel this hot air through ducts, through the whole building, right? And then they bring a return for it. They bring the return. Commercial is almost the same, almost the same with some exceptions. Okay, and so that's the hot air. The hot water, what they do, guys, is they circulate they boil the water through a boiler, so they burn gas or oil to get your hot water, and then instead of circulating hot air, they circulate the hot water to radiators, and by conduction, would that be? So so the radiators will radiate the heat. They place them in certain areas that will radiate that heat that's coming out of the hot water. That's basically the whole system for it. Talk about the branch circuits for each one of them. I want to remind you, since we're not burning electricity, the branch circuits are very simple. You're talking about 15 or 20 amp, 120 circuits. That's it, with a disconnect. So really not a whole lot to it. Major component of the heating system. This is FYI. Talk about the boilers and so forth. And then I'm going to spend some time, guys, talking about Article 725. That talk about class 2 circuit. This is a circuit that's control circuit. They call it class 2 circuit. Cool? Can you have thumbs up with that one? Class 2 circuit. Okay, so warm gas, forced warm air. We all know what that boy is. You look at the picture. So basically you burn gas, put it through a coil, mechanical coil, blow the air through this coil and get hot air and channel that hot air through ducts through the whole building. That's really what that baby does. Move the air through the whole building through ducts, and then the ducts have registers where you can open them to control the heat in the areas, right? As we all have them in our homes here. So that's basically what the hot air is easy. Everybody understand the hot air? You heat the coils and blow the air through the coils. You get hot air, channel it through ducts, and at the end have a register that you can open them and close them, fully open, fully closed, or in between to control the flow of air in certain areas. Very simple, very straightforward, and that's a supply and the return, and then you have to have ducts that can get you the return, or they have a plenum ceiling that can get you the return. Now the hot water, instead of circulating air, they circulate water. So they boil the water and have pipes that circulate, a supply pipe that goes all the way to the radiator, and the radiator have all these coils in it. And by exposing so many coils, guys, hot water in coils, that must be conduction. Conduction with the air, it picks up the heat. So it's a source of heat in that area. As it goes through the coils, by the time it goes through the coils from the other end, it becomes cold, right? Then they circulate it through a pump directly into the boiler again, heat it, and you keep doing the whole cycle over and over. And they call them hydronics, a typical term for it, or wet system hydronics. So that's basically the principle of operation for it. Typically residential, we have room thermostat, guys, that control the heat for the boiler or as well as for the furnace. Decorative manner, provide safe and adequate operation. So we'll look at the component of it, guys, in a second. And most of these are packaged units, so you don't have to assemble them. Okay, let's look at this boiler. You guys, I don't know if you're familiar with this. So here's what. Let me just draw I'm just gonna imagine myself bringing the water. So bringing the water here, and right here, we're gonna go through all these coils. How are we gonna do that, Chad, and make it make sense at the same time? So you bring the water here, and your water right here goes through coils. By the time it reaches this point, it's cold. So you bring the water back into here. That's the mechanical size, right? We don't even mess with this. So what you're doing is you're circulating the hot water, and we're forgetting that there's also a heater here that you have to boiler. It has to go through the boiler. So when it goes through the boiler, so you bring it directly from here to the boiler so there is my boiler. I bring the water to the boiler, boil it. How do you boil it? You put gas here. You boil it. Did you guys visit Dunwoody's boiler down there? Did you look at the infrastructure? We'll take you there. The burning gas like hell down there, and in a big chamber, controlled chamber, and this is these are basically hot coil. So when you heat the water here, and then you circulate it, in here, and then so you heat it. Then this pump is just to pump the water right through the radiator. When it goes through the radiator, the heat will go out, comes as a cold, and goes back again. Boil it, circulate, boil, circulate, and so that's basically the mechanical process. Any question about the mechanical process? Let's look at the electrical process. The electrical process is very simple, right? You bring 100, typically 240 or 120. This says line 1, L1, L2, say 240 volt to this system, say 20 amp circuit. Typically one hot or 2 hots, you bring to it. And this is just for the pump, guys, just a circular pump and the controller. So this is a 240 pump, right? And this will feed the pump at the same time and energize all the controllers. So let's just say the circuit that we brought here for the pump was 30 amp, and these conductors were number 10. Let's just say number 10, right? So we fit the pump. Everybody's okay with that one, guys? We fit the pump, and at the same time we have controllers. So that's the power. There's also a thermostat. The thermostat have a transformer. We have a transformer here. This is a 24-volt thermostat circuit. There's high temperature contacts, guys. There's safety shutdown valve. There's line voltage gas valve. Can I get you guys to understand that this is for control? Everything else here, anybody can tell me what these are for? Safety, right? Every time you deal with gas, the last thing you want to do is discharge the gas before you start the igniting process, and you have your house full of gas, and then one spark and you have a big explosion, right? So here's the powering the pump, no problem. And here's the thermostat to control the pump, the flow of the water, right? To control the temperature. And the rest of them, guys, is all for safety. You can see right here, line voltage gas valve. So this will not close unless the chamber, unless inside the chamber there's a fire, right? Because first you start the pilot, right? Start the fire, then you put the gas. You don't put the gas and then you start the fire. Because if you put the gas and the fire doesn't start, now you're pumping gas through the whole building. Any question, guys, about this system? What's our involvement in it? Very simple. You bring the 120 into the whole system. Everything, almost always the safety guys are built into it. The control almost always done by others, the mechanical contractors. But we will probably put conduits for them. There are two. This is called class 1 circuit, guys, because they're safety circuit. They classify them as a class 1 circuit. Typically for commercial, industrial. Class 2 circuits, residential. Any comment, guys, about these? The control. All this stuff, I'm not going to go through it. All these are part of the mechanical system. You guys read it on your own. We're interested in the electrical part. A couple of things, guys. The thermocouple. They have a thermocouple concept. Now, this is how they do control. You don't have to know that. It's just FYI. They have these two dissimilar material, and when the pilot comes up, it heats this material and it creates a microcurrent that will be sensed by the controller as the pilot is on. So we open the gas valve. Does that make sense? So these are part of the whole control system where they bring the pilot here and start heating this similar material. Because of this similar material, you create a flow of electrical current, very micro milliamps. We're not talking about hundreds of amps, milliamps. These milliamps, they're becoming a current source. They will be sensed by the controller as, guess what? The pilot is on. So now I can release the what? I can release my my open the gas valve, so I start the burning process in the chamber. So just be aware of that one. They have multiples of them. They put them in series too. Okay, the main part of this one, guys, is really the class 2 circuit that I want to talk about. My class 2 circuit. Class 2 circuit. These are very, very important circuits. We have class 1, 2, and 3 circuits. This one is limited. They are limited. All these circuits are limited in power, not in voltage. We have a whole article 725 that deals with them. They are not lighting circuits. They're not power circuits. They're not equipment circuit. They are control and signaling and power limited circuits. Everybody understand these are? So you guys have not done this. With me, you did the power layout for the receptacles and the mechanical equipment, and you did the lighting, and you're done. There's another 3 circuits that they use. They're called class 1, 2, and 3 circuits. These, as I said, for remote, we'll see a couple of pictures here, remote signaling, for control, and for power limited equipment. For example, I have a damper. Later on, we talk about these more, guys, in commercial. They use dampers to open and close so they can have air exchange in out. These dampers are running at 24 volt. These will be class 2 circuits, class 2 circuits, or class 3 circuits that's going and opening and controlling this damper. Like we say, class 2, 1 and 3, guys, will go on them in the commercial. Typically for the commercial industrial, class 1 is going to be our control circuit. Let's look at this picture. There's nothing summarized it better than this picture, guys. Remote control and signaling. Here's how they define the remote control and signaling circuit. If you can see, here's my remote control. I have contacts with equipment that will define your remote controls and signaling. So there's a couple of, I can't read it here. So that, oops, let me go. I'm almost done with that one. Let me go into my actual pictures because it zooms on it. Okay, let me go into the control first. All right, go back. There you go. So this one, guys, remote control signaling power limited. So you can have overcome detection device for like a security system. Thermostat would be a class 2 circuit. Security system, the chime, if you have the chime in your house, that would be a class 2 circuit. Security system, a 24 volt security system, that will be signaling. Security system in your building, that will be signaling, class 2 circuit. So a bunch of these, the difference between the classification, which we'll go over as we move into the commercial, guys, is really how much. Here's how you start. This is how I understand it. You have your option. You will start first with a class 2 circuit. Class 2 circuit, guys, your start point. Now, if you ran out of voltage or power, your main concerns with them is voltage and power. Class 2 circuit is limited in the power. I think it's 100 volt amp. That's all that you can get out of it. And limited in the voltage for, I think, 120, up to 120. And most of them are 24 volt or less. Now, if you need more power or more voltage, you go up to number 2, which will be class 3 circuit. Now, class 3 circuit can get you bit higher voltage and a little bit more power. Why would I use higher voltage? Why do I care about the voltage? Take this, Darren. You have a sensor, a control circuit sensor, and the sensor is 300 feet away from the control panel. If you send a 24 volt 300 feet away, at the end of the line, you're lucky if you can get 5 volts. So what happens if you, at the end of the line, you have 5 volts? Do you think this sensor is going to pick? It's not going to pick. It doesn't have enough voltage to pick, or alarm signal or something. It doesn't have. So higher voltage guys can push the sensors and the equipment further. I can pull information from further distances. Higher power can power more equipment. If I have an alarm signal that I need it to go on at 24 volt, I need 5 of them to go on. I might run out of juice, out of power in class 2 circuits. So I up to class 3 circuits. Can I have a thumbs up, Chad? So when we ran out of voltage and out of power, we go to class 3 circuit. Now what happened when I ran out of power in class 3 circuit? Because class 3 circuit can go up to 300 volts with limitation on the current. We'll go through this in details, guys, in the commercial. But what happened when I ran out of voltage? Now remember, these are for control and signaling only. Control signaling, and they're not power and light. Control and signaling. What happened if you ran because you put too many coils to open and close the contactor, too many alarms to turn on this fire alarm system? What happened if you ran out of them? You're going to go to the bar, get drinking and mad, right? Or no problem. The solution for you is to go number 3 to class number 1. Now, class number 1 circuit has the same thing, has no voltage or power limit. So a class 1 circuit, there are 2 types. One of them is power limited class 1 circuit, and the other one is non-power limited class 1 circuit. Class 1 circuit, guys, they use a lot in an industrial plant. So you have a control, you have magnetic starter that big, and you need an energizer coil that big. You almost need probably 2 kW to energize that coil. So if you put a class 1 circuit, it wouldn't even sense it. So you send the 600 volt control circuit, 600 volt, up to 600 volt control circuit, that can give you as much juice current as you want to get that boy to energize. Can I just get you to understand that's how we start them? First, class 2 circuit, we want more. Class 2 circuit can cover a lot of stuff. Security system in your house is class 2 circuit. Thermostat is a class 2 circuit. The chime in your house is a class 2 circuit. Why? Because they don't need a lot of power and they are not far away from the controller. So the voltage 24 volt will get me there, right? Now you need more power, you go industrial commercial, you need more power, or the sensors are further away from the controller. So what do? You go to class 3 circuit. Class 3 circuits still have limitation on the power. Milliamps. You don't have a whole lot of amps you can pull out of these. So you need more juice. So what do? You go to class 1 circuit, non-power limited. Can I have thumbs up, Chad? All this information that I told you guys about is in Article 725. Article 725. In the state of Minnesota, we have power limited technicians. They can only work on the first side, that one here. In a class 2 circuits, class 3 circuits and class 1 circuit non-power limited is you as a journeyman is the only one who are allowed to work on it as a master journeyman. You can't have a power limited technician work on a class 3 or class 1 circuit non-power limited. Okay, so that's basically what this is. Talked about the disconnect. A couple of things, guys, about class 2 circuits. You can't put the class 2 circuits in the same conduit with the class 1, with the power circuits. You have to be separated. So this is why I'm sure, Jamie, my friend, when you go to your furnace, you're going to find a conduit going in here and another thermostat wire attached to that conduit. That's okay if it's going to the same source. But you don't see, what you don't see is you don't see that the thermostat wire inside the conduit. With some exception, you don't see the class 2 wire. Can you guys see the class 2 wire? Can I put it right inside the conduit? No. You have to separate class 2 circuits from power and lighting circuits in every conduit, every box, every switch. The only time they can meet is when they go to the equipment, right here, to the controller.
What's the same with Cat5 and stuff?
Yep, like Cat5, absolutely. Cat5. Class 2 circuit could be a Cat5 circuit too. You could use Cat5 to be a class 2 circuit. Typically, these class 2 circuit guys, typically they use 16 gauge, 18 gauge, and sometimes 20. These are typically, now can you use higher AWGs? These are sizes, right? Everybody knows AWG. can I use 14 and 12 and 10? Yeah, no problem. But you really don't need them a lot unless you have a voltage drop issue, you wouldn't go. That's what we typically, 16 and 18 is the most common with them. Most common with them.
We would do some ones that are wrapped in foil
The-
for the old school for like sending electrical data
Okay.
for computers, and we had to use them like they had to go with like the power circuit and the same
Multi-conductor.
multi-conductor wrapped into.
Okay, yeah, where the signals and the power all in one. That's only allowed if you're going to the same equipment. You can't use it to go to a different equipment, only dedicated to that equipment. A couple of color coding here for you, for the control circuit, if you guys don't mind me. Oops, almost busted that. So if you have showing the color coding for a class 2 circuit, here's a class 2 circuit, guys, up to number 12. So if you have a 12 conductor, so that will be, let's just say 18-12. I have a cable, thermostat cable 1812. Now we don't use this one in residential. Typically in residential we use 18 or 16, 2 or 4, right? 1812, this is the color code for them. Now that's not code, that's other codes. So each one of these 12 is going to have red, white, green, blue, yellow, brown, orange, black, pink, gray, tan, and purple, up to 12. And you can use them for multiple things. This is one of the only places where you can use a green conductor to carry current. Where can you use a green conductor to carry current in the code? Green conductor is always equipment ground conductor. The only place you can use a green conductor to actually carry current, control current, is for a control circuit. Just that was also on a journal exam. If you can you use a green conductor for other than equipment grounding conductor and bonding? Yep, that's an exception. Class 2 circuit. Okay, so that's your thermostat. Talked about that boiler thing. Couple of high thermostats. So the rest of them really is a 24 limit switch boiler. This is really interesting because it shows the boiler for you guys. And I know we. So here's I have my 120 to the boiler. We will visit our boiler down here, guys. You have, let's just say you brought a 20 amp to the boiler here. 20 amp to the boiler. So this is just only to do the control. The burning here, guys, is happening through what? Gas or oil, right? Oil in this case, it's an oil burner in this case. Oil burner, you're burning oil. And all these, this is a thermostat to control the burning process, and flame detector. Why would you need a flame detector here? Because you're not going to release the oil or the gas until you sense that there is fire. So you can start the burning process in the chamber associated with it. The most important things when you deal with gas, especially gas, guys, is you do not want to release the gas until there is a source of ignition. If there's no source of ignition and you release the gas, you just turned your house into a big bomb. And we hear it all the time, right? So that's the most important. That's where the flame detector, you have a detector. When you detect that there's a flame and you wait until the flame is there, established, then you release the gas. Now you start the controlled burning process, called controlled burning process. And everything, guys, is inside it. Talked about these. Thermostat. Okay. Any comments, any questions about these? I have a few things I want to talk about the class 2 circuits, and then I'll let you guys go. Class 2 circuits. Rule number 1, you can't put them in the same conduit boxes like we said. Rule number 2, if you put them in a cable, you have to separate 2 inches. You have to separate them from other cables 2 inches. You can't mount them on the same conduit like this conduit here. I can't put a class 2 circuit right on this conduit unless that conduit is feeding that particular load that I need to control. So it has to be associated with it. Otherwise, I can't use it. I have to have my own support. They have to be class 2 circuit have to be done in workmanlike manner. I mean, neat and workmanlike manner. So you can't just flub them. You have to tie them If you put a class 2 circuit in a plenum ceiling, it has to be plenum rated circuit. You put them in a riser, floor 1 to floor 5, it has to be riser rated. So all these guys from article, you can read them in page 519. Class 2 circuit must start with a power limited source, always. A power limited source, guys, always a transformer or an electronic device. So you bring a 120 to a transformer, the transformer take it to 24 volt now, and the transformer have to have a class 2 circuit label on it. Have to have a source, otherwise it can't be class 2 circuit. You have to start with a source of power, class 2 circuit. Most of them, guys, have limitation on 120 20 amps to a class 2 circuit. So you can't go on the primary side more than 20 amps. Class 2 circuits cannot have a voltage higher than 150. The circuit, typically they're 24 volt, but you can go as high as 120 on a class 2 circuit. The transformer have a limitation, guys, on the primary. You have to have, you protect it from a 20 amp circuit, the primary of the transformer. All these guys in page 519, you can go right through them. I'm just picking some of them. Workmanlike manner. Okay. And the same conduit. So there's a few things, guys. And later on, I walk you chapter 9, table 11A and 11B, guys. I don't know how many of you have been there. This will give you the limitation of the power, voltage, and current on each one, on each one of these classes, on each one of these class circuits. In 2014, what they're introducing, I don't know if I've seen code 2014, guys. They're introducing something called suspended ceiling power distribution system. Anybody heard about that? It's called suspended ceiling, like this, power distribution system. The reason why I'm saying this, because that system is a class 2 circuit. So the way they're going to work it, this is in 2014 coming. 99% of the time it's going to be approved. It's there. The way they're going to do it, guys, see all these railings over here? So they're going to have listed suspended ceiling where you can put your tiles. See all these tiles I said there? And right above the railings, you're going to have electrical wires, bars running along all these railings in every direction. Of course, they're listed equipments. So they're going to give you mechanical for the, so you can put your tiles, and their electrical bars running, one positive, one negative, 24 volt, okay, along the whole suspended ceiling. And then if you have a 24 volt sensor, guess what you do? You just go clip on the top of that railing and you get your 24 volt sensor. That 24 volt sensor can be, guys, occupancy sensor, or it could be any signal. So you can use it. That's why they call it power distribution system, because you can use it for lights, LEDs. Here's your LED sitting there, and you need, this is an LED fixture, and I want to burn it at 24 volt. Now you just clip it on that railing, and you're off and running. So it's a power distribution. It's a wiring method, almost. All of it as 24. The reason I'm saying this, guys, because it's a class 2 circuit, and this railing must be protected right here, must be fit from a circuit breaker that's not more than 20 amps, and it has to be landing on a transformer that says class 2 circuit. On the primary will be 120, on the secondary will be 24 volt class 2 circuit. So that's another application now in the pipe for a class 2 circuit. Any comments, guys? Any questions? Any comments? Any questions? So please pay a lot of attention, guys, to class 2 circuits. Please read this chapter. There's a few things about class 2 circuits. Just read them. Okay, now just summarize, since you guys, and I'll let you guys go. Now, when we talk about circuits right now, we have, you guys did with your friend chat something called lighting branch circuit. Number 2, we have power branch circuit, right? We know what a lighting and power branch circuits. I dare to say also 1, 2, 3, we have equipment, which is special branch circuit like air conditioning, heating, cooling machines. These are typically the branch circuits that you have in your building, right? These are 3 separate branch circuits. Then right underneath it, you're going to add 4 class 1 circuit, 5 class 2 circuit, 6 class 3 circuits. Do you see where these circuits lie under these power? First the power, and then these circuits. And again, these are for what? Control signaling. Control and signaling.
So are they going to be three different voltages?
Voltages, these can run here. Typically, you run from 120 all the way to 600 volts, right? You can run any of them, 600 volt. These, typically the voltage on the class 1 circuit can go up to 600 volt. In the class 2 circuits, 150, I believe. In a class 3 circuit, 300. See, the voltage is different in each one of these. These ones can go, again, when I say up to, does it mean, and let's just start here instead of 120. These are up to 600 volts, you can get them. These are, so you can see that class 1 circuit non-power limited is almost like one of these red ones. Can I have a thumbs up? We understand, Chad, the difference between these 3 branch circuits as well as the power circuits.
So they're differentiated by voltages, it's not necessarily
By voltage and power, I didn't show the power here, by voltage and power, as well as function, what they do for living. These 2, they do for living, they do control and signaling. The last 3, these for living, they do lights. For living, they do power, like receptacles. For living, they do equipment, like HVAC equipment and other owner equipment. Any comments, guys? Any questions about this? I can't emphasize sticking these blue ones right at the bottom so you understand where, when you hear about class 2 circuit, you don't get confused. Did you guys touch about class 2 circuit with us? Not a whole lot last year. The rest of it. So you'll hear Chad talk about them as we move on for chillers and air handling units a lot. EGID company has a whole company that does with power limited technician stuff. A whole section of the company. Okay, that's all I have. Thank you.